Part 2 of writing a multiplayer platform games with continuous delivery. In my past, even before creating the first video, I was working with multiple game libraries, but I always wrote my games kind of ad hoc, so without any rigor. This time, I'd like to approach it with a better hygiene of work, so to speak. So I'd like to create it with acceptance tests, continuous delivery, TDD, CI, and all that. In my previous videos, and I'll post a link to that in the description, I created a walking skeleton with one acceptance test, which wasn't really an acceptance test, but more on that later. The result of the last video is a basic game with rudimentary physics and a single snapshot test. I shared it in a closed group of continuous delivery aficionados, and I gathered valuable responses and reactions to the first video. I'll mention some of them. If I mispronounce your usernames, I'm very sorry. I'm trying my best. And in order of me writing them down, Jim Sai said it was a really cool thing I did. Thank you very much, Jim. He also asked whether I was only building ATs and intentionally ignoring unit tests in that session. Well, I didn't want to ignore unit tests, but I did start with an acceptance test to drive it outside in. I hoped to use unit tests eventually to drive the implementation at a finer level. I just didn't get a chance to do that at the time. Then I got valuable responses from Django. We touched multiple topics here. He pointed out quite correctly that the tests weren't really acceptance tests. There was a bit of misunderstanding on my side there, because I used the word acceptance test for it to mean that it's definitive for release, i.e. If you push, if they pass, you push. I wanted that predicate. So if true, then deploy. That's what I wanted. However, Django was also correct in pointing it out that an acceptance test is actually a test that includes a user perspective. So in terms of games, the acceptance test would use inputs like move right, move left, jump, stuff like that. Additionally, another member, Kay Fisher, mentioned that you're supposed to be able to drive the implementation using acceptance tests. And with snapshot tests, like by definition, you can only assert after the fact what was generated, sort of like approval test. That leads me to believe that some kind of acceptance test, a proper acceptance test, is necessary to allow me to drive the implementation forward. Snapshot tests won't do that, because I need my test to be able to query the scene model to read the positions of the element on the screen, and that's what Django suggested. Steven then joined the conversation with the insight that we'd need some kind of model similar to the DOM model from the web, where I could have a core of a game that's doing the heavy load, and it would communicate via an abstraction with the rendering library. Then I could have two sets of tests, unit tests for the core, and then the other set that would stub the scene models to the test wrapper of the rendering. And of course, that's a very good idea. I thought of a DOM alternative myself for games, but I incorrectly assumed that building it would take more time and effort than to actually create the whole game. Kay Fisher came by and mentioned that making this model is actually a good thing, because I can choose to make my model as simple and as narrow as I need for the purpose of the game, whereas the DOM is this hellishly complicated, big, rich thing. I also got a lot of useful tips from all of the members. Django suggested that he needed to fix tiny rendering differences due to false negatives in his games. Steven suggested that for games, due to their very nature, it would probably make more sense to drive the implementation inside out. And I agree with that. Kay Fisher suggested that we will need our own waiters, like wait until something appears. And we'll also need to abstract away the frames, the time, and the physics. So when we adjust physics constants like gravity, the test shouldn't really fail, except for the test for gravity. I'll skip the rest of the conversations. I think I summarized it pretty well, and I'll get ready for the next increment. Before I start coding, I'll just say two things. First, I don't like that the implementation of the game is coupled to the UI library, so we need to fix that. And secondly, as it was pointed out to me, my acceptance tests weren't really acceptance tests, so I couldn't drive anything with them. I would like to test drive everything. And in order to do that, I need to simplify this game greatly. So I need to remove the platform, remove the jumping, remove the gravity. I will just leave the player moving left and right. I'll test drive the user interface and the logic and render. I'll start fresh. I want to acceptance test drive it, so I need a clean slate. Before that, I'll save the current version as a prototype branch so that I can take a look at it when I need, but I'll work on a new branch. First, I'll create the core of the game. I think in the core, I will only have a player for now. The player should be able to move left and right. When he moves, we'll update his X coordinate. Actually, let me design a bit of a data flow first. I will definitely want the game state that holds the position, the velocity, health, gold, and stuff like that. Using that game state, we'll be able to create a view model that will contain the details about the visuals, like rectangles, left, right, colors. I don't want the game state to depend on the view model, so the view model must depend on the game state. I guess I can render the view model using the Pygame library, which will put the view model on the screen. I'll also use the Pygame library to input the controls and the actions that will go to the core to update its state. I want a layer between the core and the Pygame, so that the details of the library are abstracted. So I'll just name it the game. Not sure I can really call that an architecture, that's more of a data flow, but I'm fine with that for now. Alright, I'm thinking now, what's actually stopping me from being able to actually release this game so that we can have CD? And that's the controls. We can't move the player yet. We need to react to the user clicking arrows to move the player. Obviously, the game itself won't get the arrows from nowhere. They will be supplied by the Pygame library. So we need the test to press the arrows using the Pygame engine so that the game can read them. I'll create this Pygame engine that I can use to tell the Pygame that the keys are pressed. By hiding that in a class, I don't couple my tests to the Pygame, which I think is alright. Now, how do I implement that? I guess I could send actual keys to the actual OS window that the Pygame initialized. I'm not sure about that. Also, I've seen some people monkey patching or mocking the static test methods, but that sounds like a horrible idea to me. I'll try to find something better maybe.
A few moments later.
I think I got it, and I'm pretty happy that I managed to send the keys to the Pygame, actually using Pygame public interface. I think if I ever have to update Pygame, I think that will pose fewest problems. I guess I'll just move player left now, and we're done with the controls. Since we can move the player now, we should be able to create an executable that the user can actually run. I will say, I don't really have an idea how to test drive that executable. I guess maybe I could have extracted the main class. I would like the main to start the game so it can initialize Pygame and then tick the game in a loop. I guess I could either abstract the game or the library, or I could just stand the whole process up. Not really sure about that. There must be a way to test drive that, maybe using London School or something like that. I'm not gonna do that here. I really feel bad. I'm really sorry. Okay, I can see that the game started, but the window doesn't show. I bet it's because I didn't initialize the Pygame view. So let me do that right now. And now we can see the window. We don't render yet, so I guess I'll just print the player position in the console or something. And let me just run the test really quick to make sure everything's working. Okay, appears fine, but I see the window is flickering briefly during the execution of the tests. I don't think we needed that last time, the flickering, so maybe I can only initialize the view in the Pygame during the main execution and skip it in test. What do you know? That was simpler than I thought. When I run the game now, I can see the window, but the tests are headless. Awesome. Black screen is a little boring though, so I guess now it's time to actually draw something. I would like to draw it using a view model that's created based on the game state, so I'll start with the view model. The view model will represent the player with its coordinates and the body. I would like the player to appear as a rectangle, for now, of size 100. And the coordinates of the view model should depend on the position of the player. And great. Having that, because we're doing continuous delivery, we can actually use that view model in our executable. I don't have anything to render it yet, but I'll just print it. I'm pressing the arrows now, and I can see the view model changing position. Sweet. It bothers me slightly that I can't quit the game and I have to terminate the process. I'll try to make the game exit gracefully. We already have key inputs, so maybe I can try to close the game when the user presses the escape button. In order to test drive that, when the user initiates the close procedure, we need to be able to actually assert that the engine quit. So I'm going to assert whether the engine is not ready. This whole test means when the user presses escape, then the game should unload. Let me just pause this test right here, and let me create the isReady method in the Pygame engine. Let's go slowly. Initially, the game engine is not ready. Then, after we have initialized it, the engine is now ready.
A few moments later.
Luckily, I found out that I can check if the game has unloaded using Pygame public interface, so I don't need to do any hacks. Oh man, I can see that the tests depend on each other. I think that's because previous tests initialize the Pygame, but don't actually unload it. So I'll need to unload game engine after each test. I think I can do that using PyTest fixture. That fixture basically just decorates a test, like a higher order function. It will call the code before and after. Also forget that classes in Python aren't hoisted. So, well, I'll just extract that one. I think this one fails because the closing is in the tick, and I didn't actually add it. Let's try again. Good. Now that the tests with escape are passing, that means we can actually run the app without any changes to the main. The game should exit when we press the escape key. And it does. It closed. But there's an error when we stopped the game. I'm wondering whether that's just a fluke or is it more reproducible. But yeah, it happens every time. That's actually good. I think the error is caused because of the fact that after the game has ended, then Pygame still tries to do something here in this loop. I think we need to stop the game from looping even if the game is finished. So we'll need something like game is running in the loop. We already have tests that deal with quitting the engine, so adding that feature should be easy. The game is initially not running. But if the game has started, then it is running. And yet, if a game finished, it's not running again. We can test drive that by asking the engine to send the escape key, for example. What again? I think it's because the engine fixture was only used in the other file. I think I need to reuse the fixture between all of the tests somehow. Right, I forgot the game needs to tick in the test. Finally, when I run the game now and I close it, it should exit gracefully without the error. And it does. And now, I can exit the game using an escape key, but not using the close window button. Let me fix that real quick. We'll ask the engine to click the close button, and when it does, the engine should not be ready, because the game unloaded.
A few moments later.
But we also need to stop the loop, so the game should not be running. We've got a duplicate here, but I can extract that easily. I'm pretty sure the game will unload now on the close button. And it does. So to recap everything, we've got a black screen, but apart from that, the game state, the view model, the controls, and the loop are in place. The only thing left to do is render the view model on the screen. I'm wondering how to do that, maybe using snapshot tests or something else. If you guys have any idea how to test drive the render, I'm very happy to hear some suggestions. Also, regarding the executable, I'm still wondering what would be the good way to test drive that. It's not really complex. I only needed to start the game, so it can initialize PyGame, and call the text in a loop as long as the game runs. I'm open to every suggestion. Thank you very much for watching, and I'll see you in the next one.